Alright, might be a good time to review what we've done so far. In the course pack, if you look at the week 10 materials on 151 and start working your way through, we've seen some 3D modeling techniques involving wireframes. We've seen why wireframes are a little bit ambiguous, hard to work with. We've looked at surface modeling, and we can identify a surface model. And we've talked about solid models and the advantages of working with solid models. You've seen how the Boolean commands of union, subtract, and intersect work. We talked about 3D workspaces and how, since you're already so familiar with the 2D drafting and annotation workspace, it'd be easier probably just to add some 3D tools to it instead of switching into the 3D modeling or the 3D basics tool spaces. Okay, and now we know how to get the 3D tools on our home tab, or along with our home tab. We're working in the modeling panel, and we've worked with the primitives, and we did work with the extrude command. Again, super important that we leave the solid history button on while we're working, and you'll see as we're continuing to work how that'll save our bacon from the fire. Here are our solid primitives that AutoCAD comes with. You saw how the view cube can be used by clicking on corners or edges or faces to reorient yourself in space. We saw some visual styles and how they change the appearance of the graphics on the screen. Talked about the extrude command and how we can take a 2D shape and turn it into a 3D solid, as long as we're working with polylines. Right? We talked about how to find out things like volume and mass properties using the list command and the volume command and the mass prop command. You hopefully know that the world coordinate system is what tells AutoCAD which way is up, and that's kind of an important thing. And if we look up in the corner and we see unidentified coordinate system, we want to switch it back to world coordinate system. Talked about the right-hand rule and how that ties into world coordinates, how your middle finger pointing perpendicular to the X and Y orient you in 3D space in case you're lost. We saw what dynamic UCS does. It lets you draw on surfaces that are already there, faces that are already there. And we saw how the gizmos can help us to move things around or to rotate in 3D space. And while some of the commands for modify do work pretty well in 3D, some of them are entirely useless. So that's kind of a quick summary of everything we've talked about. What we want to do is we want to give you some practice. The only way to get comfortable with 3D modeling is to practice. So here's what we've got. We've got our practice exercise number 1. You'll start using your template, and you're going to make a new layer. So create a layer called Part 1. Okay, now the color for your layer can be any of the light colors. At printing time, if you're using white, well then your model's going to be a big black blob on the piece of paper. Same thing with these dark colors like red and blue, even magenta. So try to stick with cyan, green, yellow. Number 40 is an orange color. Number 30 is a peach color. Anything that's light is an acceptable color. Okay, your job is to create some simple 3D parts. Okay, and your options are to create them with 3D primitives or to draw some closed polylines, circles, rectangles, polygons, whatever you want to draw, and then turn them into extrusions, right? So we'll be putting each part on a new layer so that they're easy to distinguish one from the other. When you're all done, you're going to take your parts and stick them on the layout tab in the viewport. Okay, and that gives you some details here on how to set it up for printing. Okay, so the title of the drawing is 3D practice number 1. It's drawing number 20a-10a. And here are the models you're working with. All right. So now I don't want to get crazy and have to put a dozen dimensions on each of these to make them understandable for you to model. So I have a little simple system here for you to be able to size things. You see on my isometric graph paper here, there's a bunch of little isometric squares, right? So here's the deal. Each square is going to be 1/2 inch by 1/2 inch. So when you're trying to figure out how big something is, we'll count the squares. And I know that's kind of primitive, right? But we're trying to get our brain wrapped around modeling, and this will get the job done. Okay, so for example, the distance along the top here, right? How many squares? 1, 2, 3, 4. So 2 inches, right? Half, 1, 1.5, 2. How tall is this thing? Again, we're just going to count squares. Okay. How wide is this thing? Count squares. 1, 2, 3, 4, 5, 6, 7, 8. I lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. 4.5 inches long, right? So use the squares to figure out how tall things are, how wide things are, how deep things are, where things are. Okay? And this will be a nice simple system to use to get us started. So our first few involve just drawing the shape and then pushing it back with some extrusion, right? That'll be 1, 2, 3. And then when we get to 4, 5, and 6, we see we can't just draw any one shape to create these. We're going to have to draw a couple of shapes. These are going to be made in multiple steps, some of these models. Now, when you're done, it's really important that everything is unioned together. All these extrusions or all these primitives have been unioned into a single part. Okay? So make sure 4, 5, and 6 are a single part when you're done, just like 7, 8, and 9. Okay, and as they go on, they get a little bit more tricky, right? They're a little bit trickier as we get deeper into the assignment. So here's our 3D modeling assignment to get us going. There are 12 of these. We'd like you to do the 12. And again, when they're all done, we're going to set up a viewport on our layout. We're going to show them in the viewport, display them, make sure they got some good spacing, and then we're going to get them ready for printing. And you're going to submit them the way that your instructor asks for them, either as a hard copy printed out or online as a PDF.